Okay, good evening. We have this presentation or this lecture will be about bipolar high voltage direct current, and the abbreviation it's HVDC, transmission lines. It's by student Ali Al-Shara. The date it's approximately it's 7th of August 2023. So as the introduction, we have the first of all, the definition of HVDC transmission lines. So now I want to talk about that. We are using these systems to transmission or to transmit the power between two cities. And usually we are using that to transmit high power long distance between these cities. So that's the definition. And the high voltage DC current, it's using mainly like constant or fixed current, not just a variable current. So that's the definition of the transmission lines in the high voltage DC current. Then let's see a comparison between the AC transmission lines and the DC transmission lines. So the AC transmission lines mainly have advantages and disadvantages, and also the DC have advantages and disadvantages. But to compare between them, first of all, we have that the AC current using for less power, or we are using them for less power. On the other hand, on the other direction, which we have DC current, we are using for more power or high power to transmit between cities. Another point so we can talk about, it's about the voltage that we are using in both of them. In the DC, we have megavolts, we are talking about megavolts, kilovolts, and something between that. But for the AC, we have like 100 volts or kilovolts, so it's something or the range or range in something between that. Then we can talk about the controllability of AC and DC. For the DC, we can control the system and control the power or the direction of power if you want to transmit it from city 1 to city 2 or from city 2 to city 1. But in the AC systems, we cannot control the power direction. So it's not something in our hand. Now, also, we can talk about the losses in the DC transmission line, which also is like lower than the AC systems. So we are using DC lines because we have a lower losses in the DC lines. For the AC lines, we have more losses about the power. So the transmission lines in the DC have more advantages than the AC lines. Now, for me, if I want to use like between cities, I can use the DC lines because it has a less power. The controllability is with me, and the volts, it's also with me. The range of volts, it's also with me. So that's the benefits for me. Now we can talk about the main components of the high voltage DC systems. So we can see the system here. We have the AC system at the left side of the picture or the diagram here. We can see that the AC system has at the right of the AC system that we have transformers, which we call it as step-up transformers, and then we have the power electronics, these thyristors. These thyristors mainly used for or to change from AC to DC. So these thyristors, the main goal from them is changing from AC to DC. So these two thyristors at the left side, we can use them to change from AC to DC. And these two thyristors at the right side, we can use them to change from DC to AC systems. And then we have the transformers at the right side of the diagram, which we can call it as step-down transformers. Then we have maybe the houses or the facilities that we want to deliver the power to them. So that's the bipolar or the main diagram of bipolar high voltage transmission systems. Also here we can see a specific diagram about that. So we have the AC system one, or the main components of the AC system one, AC filters, and then we have the LCC inverter, which line commuted converters. We can call them like them. The abbreviation of them it's LCC, and then we have DC cables, then the LCC rectifiers, and the right side we have the AC filters and AC system one. So that the main, or these are the main components of the high voltage DC transmission lines. Now, to understanding the bipolar high voltage DC lines, we have the definition of the bipolar high voltage DC transmission lines. So for that, I can use this diagram of one, then not this diagram, or also this diagram. We can see here that the definition that we are using two cables, one of them for the positive side and the other one for the negative side. So that's the meaning of bipolar, that because we are using two polars to transmission the power between the systems. And also the configuration and the working principle, it's also about transmitting the power by two cables. Also for the faults, if it's happened or the faults happened here, we can use the upper side if faults happen to the lower side of the system. That's something different, or the compared to the mono system. We can call it as monopolar high voltage DC lines. That cannot be happen, because if faults happen here at the monopolar, after the fault, it's back out for the system. So we don't have the transmission lines or transmissioning the power after that fault, because the monopolar cannot handle this situation. Now, the advantages of the bipolar high voltage DC transmission, first of all, increasing the power transmission capacity. Then we have the enhancing of the controllability of the and stability, reducing the transmission losses as we talked about previously, utilization of exciting AC transmission infrastructure. So also we have to talk on the other hand about the disadvantages of bipolar high voltage DC transmissions. The complex converters stations, so the complexity is something not good to deal with. Space requirements, it needs big places or a large size to put inside it, the electronics or the stuff that we need. Limited voltage support, and also the harmonics and filtering. We saw at the previous diagrams the filters and how to use them or why we use them. So that's one of the disadvantages for the bipolar high voltage DC transmission lines. Now the applications, we can talk about using them for the long distance power transmissions, interconnecting asynchronous AC systems. So that's one of the benefits or the best benefits for that. Offshore wind farm integration, so we can use them for the integration. Also the underwater power transmission, so between two countries that they have like coastal between them, so we can transmit power between them or between the oceans. So that's one of the reasons to use this bipolar high voltage DC transmission lines. The technical challenge and the solution. We have the converter design and efficiency. So if we are using converters, that will help us to increasing the efficiency of the power transmission. As we said, it's less losses for DC transmission lines, not like the AC transmission lines. Submarines, cable technologies. Also, the submarines can use them to transmit the power between them and the country and their country or their government. the harmonic filtering and reactive power compensation. So also we have the like challenge for that for us that we have harmonic in our system, and also we have reactive power compensation. Also we have the controlling and protection system. Yes, that we control the high voltage DC lines, but also that will cost us too much, and to protect them it will cost us too much because it's a big size machines and also technologies, so that will be a challenging for us. Case studies that we have here, the North Sea Link project, we can see a picture of that from the internet or Google Images. Also Itabia or Itabu high voltage DC links, and Chinese and Jinping Sona high voltage DC lines. Future prospects for us will be the advancement in converter technology, and also the grid modernization, and smart grid integration. We have also global interconnection and energy trading. So that's future prospects for us from the bipolar high voltage DC transmission lines. And that's it. يعطيكم